Yeah, since there was no clear topic, I prepared a couple of slides around the trajectory memory. I don't know, Jeff, if you had anything else since yesterday that you would want to
I
talk
I
about.
did I did an image or two as well. I could do that.
Okay, cool. Yeah, do you want me to start or do you want to
Sure.
start or how do
Well, why
you?
not?
Okay.
That way I can
Um,
that way I can adjust what I was going to say to sound smarter. Like, oh no, of course,
well,
as opposed to sounding stupid. Anyway, sorry. Okay, you want
so
you want me to go first? I just prepared a couple images that essentially show the mechanisms laid down on a cortical column and talked about some of the
yeah,
implications.
I did a similar thing. So maybe I can
Well,
I can
we
start
can look
with
at your
some
yeah.
first
Start with
slides.
yours.
So basically, yeah, the things that I prepared, maybe I'll just give a high level slide view real quick before. Uh, so yeah, I basically have one slide of comparing trajectory memory to what we previously had, some kind of prerequisites and examples, and then most of the slides are open questions and discussion points. And
What you
then
said you had one or two slides. It looks like you got like
it's like a
100
it's like a slide
slides.
that builds. It looks like multiple slides, but it's like
it's
the bullet points add.
it's
Um,
multiple slides.
Yeah, and then basically going back to the requirements we wrote down over a year ago for modeling object behaviors and seeing what all does it solve, what's still unclear, and then one slide on using those for outputting actions, kind of what you wrote on Slack the other day, Jeff. So
Okay.
um,
Wow.
yeah, if you want, I can just do the first three, and then we can go.
You got so much more material than I have. I mean, I barely have one of your slides. So yeah, sure. Why don't you go?
Okay. Um, Let's see. And this is just my understanding of things so far. So maybe it's also just a chance to synchronize our understandings of this new proposal. So I thought I'd kind of go back to where we started. So this was where we started kind of in February last year, where we had this realization, okay, object behaviors could rely on exactly the same mechanism that we use for static morphology models, where instead of getting static features and storing them at locations, we're getting changes and storing changes at locations. Um, and those can also receive a time signal and then they're pulled into a behavior ID, similar to how we pull into an object ID for the static models. And basically, the same machinery twice in a column, and and then eventually, and we went with this for a long time, and eventually thought, okay, since it kind of looks like the same thing twice, we could also split it into two columns, and that way we don't need two reference frames in one column, and it's basically the same architecture for every column, and the only thing that's different is the input to the columns being either changes or static features. Um, and then so
But I,
now, as far as yeah,
can I just add a little flavor to this? One of the reasons we went with the first proposal up above is that it always occurred to me you have in layer four and layer three, you have these similar mini columns. They have the similar orientation preferences, but in layer three, the cells respond to moving edges, and in layer four, they respond to static edges. And so I always felt like, oh, those two things belong together. Like you said, change and static. You're watching a feature and it's either moving or it's static, and it always felt to me like, oh, they therefore the behavioral model, which is the changing one, would be in the same column. That's how we started. I mentioned actually we're going to come back to that. But it was partially driven by that layer three observation that these are edges that are moving. So anyway, no, it
Right,
didn't
and then
every
maybe the split the at the bottom that you mentioned, like you said, one reason was to not have kind of multiple reference frames within a single column, and then I
right.
guess the other thing was we at least with that approach, it seemed like most of the interactions happened across multiple columns anyways. So then it was like, well, why have them in the same column? So
Right,
it'll be
right,
interesting if that is different, maybe with the new approach,
right.
that there is more of a sense
Well,
that they need to be in the same column.
Well, the real problem I think with the first thing is it was a real serious difficulty to have two reference frames that are independent in the same column. I mean, that just was asking a hell of a lot. So it was like we said, we took the exact same mechanism we had for morphological models, and we said, oh, we'll just copy it. And so we had two of them in a single column is just too much. So that's a little bit more
Yeah, and
color
yeah,
on the
like Neil
color. What
said, yeah, right, and yeah, like Neil said, and it seemed like it wasn't really required to have it in the same column because when we assigned behavior to morphology, we would use two columns again as like a compositional relationship, and didn't
right,
do it
right,
within one column, so it
right,
wasn't really an advantage.
right.
Um, okay, so this clear so far? Any other questions or uh, add-ons?
This
Okay,
is
so
all the past
then
still. Yeah,
right, yeah. So this is now the new part, as far as I understand it, where we're basically going back to putting behavior and morphology models into the same column, but now with the kind of simplification that the behavior model doesn't have a reference frame, and that way, like we don't rely on this hard requirement to have two reference frames in the same column. Instead, the behavior model is just a sequence of changes in layer 3 with temporal input or context input from layer 1. And so, yeah, both exist in the same column. Behavior models have no uh, no location and no orientation representation. So yeah, no connections to layer 6. Basically, so here purple is the behavior column connections and blue are the morphology ones. And the behavior model learns a sequence of states, sequence of changes.
I guess with the no orientation, I just remember last week when we talked about this, we kind of thought it could kind of inherit the orientation from the
Yeah,
morphology
it
model.
would.
Like whatever transforms are being applied to the static feature could also be applied to sort of changing object, but it wouldn't
Right,
be
yeah.
right.
independent.
Yeah, and so I have a slide on that in the questions here that, yeah, basically what you said, we could use the same orientation that we apply here and also apply it to the changing input
Right.
to layer
Okay.
3. And that way
But
we
I
can
but
have
I
these
think
different orientations, but this one wouldn't inform this orientation down here and it wouldn't have a different representation.
I think the way I understood this is if I took an object and I rotate it in front of me, well, the behaviors of that object would rotate with it. But if I had a behavior which was like, as you said, Vivian, like go in an arc in a clockwise manner, um, and now I saw a behavior which is an arc that goes from low to high to low, left to right. Now, if I saw another arc that would go from right to below, it's like that right there, that thing. That those would be separate. You wouldn't say, oh, that's the same thing in a behavioral model. The behavioral models would say, no, one's going up and down on the object, and the other's going right and left on the object. That's
Yeah.
how that's what I mean. There's no orientation, right? It's the whole thing will orientate with the object, but those are two separate behavioral objects where if they were morphology objects, they would be the same
Yeah.
morphology object.
I mean, in some ways it feels similar with morphology, or like I don't know if it because as
This
in
this
like
isn't this
there's some symbols like a multiplication sign versus a cross, or like a plus sign, or a B versus
right,
P and D and stuff, where like we do treat them as different objects based on their orientation.
right, right.
Um, so it kind of feels
But
like it could be in both, like it could
but
happen for
personally, I,
both
I
behavior and
I don't think
morphology.
this is a I don't think this is a problem at all. Personally, but maybe it is, but I don't think so. So it's just an observation. It's
But
an interesting observation that
yeah, I wasn't
Right.
highlighting problems here. I'm just saying there's no
yeah.
connection to layer 6. So this one is not trying to infer an orientation and it doesn't have an orientation independent of the object.
But more importantly, and this would show up in the slide I created, which is similar to this, but more importantly, the inputs to this layer 3, there's nothing that locates it on a specific object. There's no child projection going into it. There's no location going into it. So it is purely movement related. There's nothing anchoring it. That pattern in layer 3, there's nothing anchoring it to a specific object in the world. It's purely it's independent, where layer four is anchored to specific object because it's using the location in a reference frame, and it also has child features, which anchor it to specific places in the world. So
Yeah.
it's like so layer three is this sort of independent collection of behaviors that could be a theory applied to any object.
Yeah. Yeah, maybe after this slide you can show your figures and then we can come back to my slides just so we have the full
Right.
picture.
You say you want me to do
Um,
that now? You want me to be
oh, I
quiet
have
now, or
like
do you
two
want me
more
to show?
points to just summarize, finish summarizing, but yeah, Jose, you had
Okay.
a question?
Yeah, quick more. When you say state plus state next to behavioral ID, do you mean behavioral state?
Yeah,
And
so basically where
also,
in the sequence we are.
okay, okay. And do we still have morphological states? I remember this was like a point of discussion the week after Milan when Jeff presented. Do y'all remember this?
Uh,
Like, there's
Yeah.
not
no
not
Jeff. You were
not
saying
yet, and I don't think there's one
okay.
yet. I don't think we've reached it. But you do say behavioral ID and state. The sequence is the state. I'm not. I think it's an open question whether this is pooled to create a behavioral ID.
Right, yeah, so
Um,
the
Okay.
state alone would likely be enough because the state would be unique to the behavior. And so I'm not
right,
saying those would be two separate SDRs, but more like the output represents which behavior it is and where in the behavior we are.
right. Well, it's contrasted to the object ID above. The object ID above that is actually a temporal pooled stable representation.
Yeah,
And at the moment, for the behavior, we don't have a stable ID. It's just the current state is unique to the behavior and where you are in it.
right. Yeah.
Question. Do we need the behavior state to predict morphological features depending on where we are in the behavior? Like a stateless opening, um, the features are going to be displaced. They're going to be at a different location in the reference frame. Or are we, I guess what I'm saying is, are we using the behavior state to go back to the canonical object or like inverse the movement again or do any of those tricks to make good predictions about morphology?
Yeah, I think it's at least in my mind still an open question. I also put a slide on that in here. Uh,
Okay.
I guess, yeah, one of the potential solutions could be to use the same mechanism we proposed for the previous option, where basically the movement stored in the behavior model can be applied to the reference frame of the morphology model. And that way you kind of compensate for the movement and you keep predicting the correct features in the morphology model.
Yeah. Okay.
Um, but yeah, there's still some issues with that. So
Right.
Ye-
I agree with that. I tried to make that work too, and I have some issues with it.
yeah,
So
Yeah,
the
I guess
same,
maybe
same as
an alternative or complementary one is more similar to what Jeff had kind of proposed and presented after Milan, which is the kind of in that case it was linking L4 to L4 between morphology columns and behavioral columns. But
Mhm.
again, I think that might not at least immediately come out of this because
right.
in that case it's L4 because it was bound to specific locations in the behavioral columns, whereas here L3 is obviously going to be a more generic
yeah, but basically
representation.
the idea that we still store different variations in the
Right.
morphology model, and then
And
depending
kind of
on which
condition.
behavioral state we're in, we would predict different features.
Right.
Yeah,
Which isn't that different, I guess, from how we proposed doing state and morphology models. So
right.
so it could maybe work fine.
Yeah, that's
Or
kind of
I don't know
the
if
key frame-like idea, but
Right. But it's the
without
state
having
is informed
separate
by
variables.
behavior instead of being informed by just static morphology.
I
Yeah.
didn't follow all that. If I need to follow it, we'll have to repeat it. If it's then we'll come back to later.
Well, basically, the thing that you present with the morphology model stores a union of features
Right,
of like all the
right,
possible places where the stapler could be, and then depending on which behavioral state we're in, different features would be predicted in different
right,
locations.
right. Okay. Yes. The problem that's a great I like that idea. The challenge of that idea is it requires a projection from layer three to layer four, right? It says um, um,
Yeah.
well, Well, in my diagram, it's obvious layer 4 does project to layer 3. So you would be making that association between unique, like if I have a pattern in layer 4, let's say I have two different morphologies I've observed on this object, maybe two different positions of the switch. So there'll be locations on the object that have stored, sometimes stored nothing, sometimes stored something, sometimes stored A, sometimes stored B. Um, those That's the union idea. Those are unique to different points or beginnings or ends of behavioral um, trajectories. And so layer 4 projecting to layer 3 is your affordances. It says, hey, I see this feature. It suggests the behavior because that feature only occurred when the behavior began or the behavior ended or during the behavior. So those are like the different states in layer 4 are sort of like keyframes tying into different states in the behavior model. Those are a lot of words. I don't know if people got lost on that, but I would have gotten lost.
Yeah,
Yeah, maybe I'll finish the last 2 points and you can pull up your diagram and then.
Okay, I'm afraid my diagram's not
before we
as
dive
good as
too deep
yours,
into
but
the other
I'm
point.
happy to do that.
But the points, I think we covered them all already. So basically, behavior model has access to time and context from layer 1. So you can use time or applied actions or something to move from state to state. And then input to the behavior. This is a kind of a crucial one that I have 2 more slides on for later. But input to the behavior model would represent the movement of the entire object. Since we don't have a reference frame anymore, that's kind of a necessary requirement, that it's not just local flow of an edge of the object, but it's how the entire object is moving through space.
Well, that's where I got stuck. I was trying to make that work, and I had trouble with that. So maybe you have some slides on that.
Yeah, I have some slides and I haven't made it work fully, but do you want to show your diagram first for additional
I'm happy
context?
to. See those diagrams. So on the left here is just a review of our basic morphology model, and there's a small thing in that I just want to point out. There's nothing new here, right? This is all stuff we know. But I just want to clear that, basically what just make it clear when the retinal, if you're talking about vision, the retinal input actually doesn't go to the cells here. It goes to the theory is it goes to the double bouquet cells, which define the mini columns. And so there's actually very little retinal input to the layer 4 cells themselves. And so these mini columns represent some feature we think about as an edge, but there's a feature. And of course, then we select the cells in there that are to form an SDR, one self-active mini column. And that just represents this observed pattern in a unique context. And there's 3 types of context we've identified. One is the context of location. So, we can associate this SDR in layer 4 with a particular location. We can associate it also with a child object's ID from a lower region. We've talked about that. And it turns out these layer 4 cells also interconnect with each other. So if there was ever a repeating pattern here, it could learn that. Typically that's not the case. If your finger or your eyeball or whatever doesn't move in the same trajectory, you wouldn't observe a repeating pattern in layer 4. But if you did do the same movement through the object, it would learn a sequence. So that's our morphology model. We don't usually talk about the internal connections in layer 4. And now here's what's going on in the behavior model. We have the same retinal input. It invokes the same mini columns, but now we have mini columns in layer 3B and layer 4, and they have the same orientation. They're basically the same feature. But for whatever reason, the mechanism is that the ones in 3B tend to have that feature moving in some direction. So literally, if they represented a vertical edge, you'd see one mini column where the edge was moving to the right, and other place you'd see the vertical edge moving to the left. And the equivalent mini columns in layer 4 would be just vertical edge. So if we just follow the logic that we've been talking about here, and the patterns coming in from the retina do repeat, meaning there's a sequence of them. And one of the surest ways of doing that is to do a smooth pursuit of something that's a behavioral pattern, or it'd be similar with your finger moving smoothly over an object in the same way. Then layer 3 will naturally learn that sequence, just like Layer 4 could. But layer 3 is going to learn that sequence, but it's going to be specifically when the features are moving. So it's taking some feature is moving through space. Layer 3B will learn it. There's, of course, a lot of interconnections in layer 3B, so it'll learn a high order sequence. There is nothing else going into layer 3B. So this is why I was saying earlier, it's not tied to a specific object. It's going to be learned on a specific object. So I'm observing an object here with a morphology model. And as we're observing it, we now get, we're tracking some movement of it. And so it'll learn this behavior as part of an object, but the behavior itself is not tied to the object. It's independent. It's nothing anchoring it to the specific object. So just a trajectory pattern. Of course, a very common canonical circuit is that layer 4 projects to layer 3. And I was looking at the details of this, and this projection really is layer 3B is the most likely candidate for this behavioral models for various reasons. So I was reading some papers about this. And layer 4 projects to layer 3B. This is essentially associating what we were just talking about, the affordances issue. This is associating a particular observed feature on a particular model with a state of a behavior model. So if I see some feature here, it can invoke a behavioral model, or if I'm moving through a trajectory and I have a bunch of keyframes in essence, those different keyframes will be associated at different points in the behavioral model. So that's our sort of affordances thing. And then the only other thing I have in here, which you also had, Vivian, is that there's this very well-known connection between layer 3B and layer 5. And layer 5 is the motor output of a column. And so it makes a hell of a lot of sense now that although I've learned this behavioral pattern, this trajectory through space through observation, so that's how it was learned, I'm able to read, the column is able to play it back in some way when it wants to. And so it can say like, oh, I've observed how to do something. Now I'm going to do it myself. And that's as far as I get with that. I think that's a very important, to me, that's a huge insight that we can play back these trajectories, behavior trajectories through here. And as I mentioned in a post on Slack earlier, we also think about layer 5 as being like a displacement, like we want to just move to some location. And I think that's consistent with this, that layer 5 cells would always be representing sort of like what layer 3B is representing. It's movement of the sensor, or movement of the appendage, or movement of something physical in a direction. And you can use that to go from point A to point B, and you can also use it to do like a complex trajectory through space, like writing your signature or something like that. That's pretty much it. It's not as nice as your diagrams, but I thought maybe just presenting them again might be helpful for people, just to see it. Oh, by the way, we still need an object ID over here on, and so that looks to me like I was again paper suggesting that might be layer 3A. That seems to be the one that projects mostly to layer 4 in the next column, the next region. I'm sorry, I'll be quiet now.
So these trajectories, when you write a signature, that's something that's kind of hard to. I don't think I could write my signature and then halfway through start going backwards. But
Right,
like
you
a
can't.
stapler or something is something that I could kind of like switch halfway through. It feels like that's something that's kind of reversible.
Well, I don't know if it's reversible. I think the way we've thought of that, Scott, is that you've observed it go both ways, right?
Mm-hmm.
You've observed it go up and you've observed it go down. And the way we've talked about in the past, those are two different behaviors. So there's a going up behavior and there's a going down behavior. If you're in the middle, that would suggest either behavior could be started, because that's like a keyframe in the middle. But if you're at the bottom, it only suggests going up, and if you're at the top, it only suggests going down. So that's consistent. And of course, something that's a simple arc. So I don't know, could I, but defining your name or even just writing anything is almost very, very difficult to do, almost impossible to do backwards. There are a lot of behaviors we do that I don't think we can do backwards. We can't speak backwards. Speech is also a trajectory like this.
Mhm.
So I can't speak backwards. I can't, I don't think I can, you know,
I just wonder, yeah, it feels like there's should be some way to capitalize on the fact that some things are super easy to reverse upon, like
well, I don't
screwing a
know.
thing and then unscrewing.
Yeah,
They're
but
literally
you've,
symmetric in that way.
yeah, but you've observed them both, right?
Mhm.
Um,
Yeah, it's
you've
something we often
observed them.
comment on is like just how much children repeat these kinds of simple behaviors when they're learning about them.
True.
Like
Yeah.
in a way that just seems really weird, I think, to an adult. Because it's like, yeah, you
Right.
just did that. It should be obvious now what will happen. But they just keep
And
doing it again
what?
and again.
Actually, I'm doubling back on myself now because I'm thinking about the screwing example and how screwing things in is different from screwing things out. Like they even have different results
They've different results. They
on
also
the
take
object.
different levels of pressure. Um,
Mhm.
and right. So yeah, I mean, I wouldn't say, Scott, that if I've only seen a staple opening, could I never imagine it going down? Um, I don't know. I wouldn't go so far. But clearly, if I have, I can't write my name backwards. I can't say words backwards. I think the actions I go through to put on a shirt, a T-shirt, for example, um, are not the reverse of the actions I take to take off the T-shirt. And I don't even know if I want to make sense. Could I take off a T-shirt by reversing the actions I use to put it on? I don't even know if that's possible. No, I can't because I'm using pressure to pull it over my head, and I can't recreate that.
Right.
So there's so many things in life that really aren't reversible. You might think like, oh yeah, it's reversible. I
Or
put my shirt
you're
on,
saying
take
the
my shirt
alphabet
off.
backwards. Like if
Right.
you learn it, you can do it. But if you haven't learned it, it's very slow and like you basically have to conjure the reference frame, like a 1D reference frame of the alphabet and like focus on the letters in series.
Yeah, or
Right,
you
right,
go through
right,
it from the right direction until you get to the point that you were at,
Right.
like you and then say the next letter.
right. So I think it's non-reversibility is I think we can accept that. And it's really easy to observe it like the stapler, to observe it going both ways, and no problem. Not an issue.
Yeah.
But I think that works much better overall.
Okay.
Jose?
Those are my. Oh, go ahead, OJ. You have your hand up.
Oh yeah. Just to make this, I guess, more about relationship between trajectories and behavior models. Are we, and we don't need to decide this now, but are we saying that a behavior model contains only one trajectory? That is, if we think about Ramy's exploding logo again, is that four behaviors? Okay, let's assume that there was like four parts of the logo exploding in different places. Are individual trajectories each a behavior, or are we saying that it's one behavior that has kind of four different
No,
trajectories?
it's the former. I mean, that was a surprising learning for me when seeing that logo, was that you couldn't possibly learn it by looking at the whole thing. The only way to do it is to follow each piece separately and learn each trajectory separately. And so that clearly, in my mind, was four separate behaviors that happened to be causally linked. Because so
Right.
we could ask the question, how do we do that? But
Or like
but really
associated by
not.
time, like they are all occurring at the same time.
Well, they're all occurring at the same time. Causal, I guess you could say maybe same thing. But I had to study one of the components only and watch it over and over again to learn what it was doing. Then I could study another component and watch what it was doing. But there was no way in the world I couldn't track them all at once, and B, I couldn't even begin to perceive them all. I mean, it was just like your brain was going, stop. But if you
Yeah.
just focused on
Um,
the one piece, you could follow it.
right. Yeah. And I think I also lean towards the former, but does that also open up for compositional behaviors then? Because collectively we call that exploding logo, but each one is not explode. Like if we were to just look at one and isolate it, we might say like, oh, this is somersaulting or this is just moving to the left or
Yeah,
something.
maybe I don't
But
know. I mean, I think it's sort of a corner case where it won't be hard to deal with. I mean,
I mean,
I can imagine. You can imagine just that logo where only one component moves around, and I could learn that. That would be just like what we're talking about here. And then I could learn another behavior where another component moves around. So I have four separately learned behaviors, and now we're basically saying they're all occurring at the same time. And by the way, it wasn't easy to do that. I mean, mentally, I found it very difficult to try to like unite them. So like given knowing where
Right.
one was, I couldn't really
I
predict
see.
where the other one was. I could say, oh, this is how component A moves. Here's how component B moves. But if I saw component A, I really wasn't able to predict where component B was. So they were kind of like
Gotcha.
independent.
Okay,
That's how
okay,
it felt
okay.
to me.
I would also say, like, especially with this trajectory memory, but also with the previous before behavior models, I don't think it's possible to have compositional behavior models. But especially with this trajectory model, uh, I think learning a compositional object would require a reference frame because you need to store where children are relative to
Right,
each other. And so with the
right.
exploding logo, I think you would rather assign them to a morphology, like locations relative to each other have the different trajectories stored on them. But that would be a morphology model that has different behaviors associated at different locations, and
Gotcha.
those are kind of synchronized in time.
Well, my picture
Yeah.
here also
Okay.
shows why there can't be compositional behavior models. There was no other input to layer 3B.
Right.
Our right. I mean, Vivian said you need a reference frame, but you also need a child. It's like so layer 3B is really a very poorly innovated layer. It's mostly the connections between the cells themselves, and it has the mini columns. Now that's not. It's not only everything in the cortex seems to protect everything some small amount. So but basically that's the rule. Where layer four, I was emphasizing layer four has both location and child inputs as context. Layer three really doesn't have those things at all. So it's kind of, but you can have lots of behaviors in a column and lots of morphology models in a column, and you could mix and match them within a column.
For the 3B input, would we also want to still support like changing objects, like child objects? Like I think that maybe the clearest one we've talked about is like the changing orientation of a child object. So like rather than just relying on direct retinal input, we would want like
Right.
the concept of stapler arm rotating. Um,
I didn't, that's a good question. I didn't think about that in this picture here. Um,
because
it
it
needs
feels
to
like
be
there's a
thought
lot of
through.
behaviors we'd want that. Um,
Well, this would show up. Remember, the way we think this shows up is that the thalamus is imposing this orientation.
right.
Um, and so the black line coming into to this behavior model picture would be changing. It would be changing the orientation, which mini columns are active would be changing due to the orientation changes of the child. So I'm making this up because I didn't think through it, but essentially, um, what we're learning here is a sequence of mini column activations,
Yeah.
and um, if something is moving, well, by definition, if something is moving through a trajectory, it's the orientation of its the direction of its movement, which is the orientation column in some sense, will be changing unless it's a linear. It's a straight line, then it would just be a sequence in a straight line. But the fact that it's moving around in 2 or 3D space says that the mini columns are already changed. So I think it's built into the mechanism, Niels.
Right.
I think we have to think about from the thalamus point of view and the child point of view and all that kind of stuff. But I think
Yeah.
I think this is built, it's already built in.
Yeah.
I also have a slide on that topic, but
Well, why don't I
the
stop
way I
sharing
was
then?
thinking about, well, I think at least in my mind, the only way we can get this mechanism to get to be general enough to fulfill all our requirements is if the mini columns in layer 3B can just use a general spatial pooling mechanism to learn the most common changes that are coming in instead of being limited to edges moving in different directions. And so that
Well,
way they could also learn child orientation changing or child ID changing, even if
Yeah.
that's a common change that
But
they're observing.
so all right. So I want to go back to what you were saying there. Um, you see over here on this on my picture here. I
Yeah.
say mini columns represent most commonly observed patterns.
Yeah.
I think that's what you might have been just talking about.
Yeah. But
Mini columns
basically,
are
that
they
they're not just edges moving in directions, but they could also represent orientation changes or child ID changes, if those are
they
commonly
could
observed
represent
patterns.
if we're right about this, it's that you're just taking these center surround bits from the retina, stick the retina for the moment, and you're running into a spatial pooler. Well, it could, and the mini columns are the results of that spatial pooler. Well, they just basically the mini columns represent commonly observed patterns. That's it. And so a lot of times the commonly observed patterns would be edges. That's the most common basis that you would come up with. But it could be anything. So I think that's what you're pointing out. This is not restricted to edges,
Yeah.
although that's what it looks like a lot. Is that what you were talking about?
Right. Yeah, exactly.
Right. So I keep bringing this up because I don't have any. I made a point of saying this. These are not edges. These are commonly observed patterns because I think it's going to be important. Though that I've never figured out exactly when it actually is going to be important, because it seems like always edges are going to be the most common thing to observe. But anyway, I think that's important to remember, and that's why I put it here. That these mini columns are not edges; they are the most commonly observed patterns. They're like a basis set and represent whatever things are being observed in the world, and just it looks like often that they're if for vision, it often looks like it's just edges. So okay, let's stop sharing again.
Hoji?
Yeah, sorry, one more quick question.
No,
So
sorry, you don't apologize.
I agree that like behaviors and like different quote unquote orientations are not like the same behaviors. Like stapler opening is different from stapler closing. But what about behaviors that happen in different time periods? So if we do slow mo, is that the same behavior, or like if a trajectory is happening in slow mo or like 2x?
Well, I
I
think
mean,
you can speed. You want to share and talk about that? We can speed things up and slow it down. There's no question about that. Just like you can write your name slowly and write your name quickly, or you can speak slowly, or you can speak fast.
yeah, and that could still
So
rely on the same mechanism we had before, which is this kind of global clock, maybe from the matrix cells or maybe from somewhere
yeah,
else that goes into
right.
layer one, and that you could speed up or slow down, depending on when the features are coming in and when you're expecting them.
And of course, interestingly, I didn't show that on the diagram, but layer 3A does have apical dendrites that would receive that kind of information, where layer 4 typically doesn't. So layer 4 would not be sort of time sensitive. It could learn sequences, but it wouldn't be time sensitive. Where layer 3A would be time sensitive and could be sped up and slowed down.
Yeah. Trying to think. I mean, I can't really think of any like counter examples that like where you speed something up, it feels like a different behavior. I guess I'm thinking about like walking or running, like, but I guess
Those are
they're
definitely
kind of different.
different. Yeah. If
Yeah,
you
they're different behaviors
if
and
you
not
tried
the
walking
same.
at the pace of running, I think
Well,
either
s-
you'd
well, this,
trip or
well, this
or there's
speed
power
walkers.
Running
walking.
is yeah,
Right.
Speed
yeah,
walkers, they walk really fast, but they look like they're walking. It's
Yeah.
really fast.
right, yeah,
Not sure what it is that they
yeah,
do.
They
yeah,
have
Put
kind
your
of a
heel
weird
down
waddle
first.
as well. I think
I
there's a
think you have to
technique to it.
put your heels down first or something like that.
yeah. Or maybe like songs. I guess songs do sound like they're like songs, even if they're slowed down. I mean, it sounds weird, but I mean,
No,
I think you probably
we hear
still
songs at
recognize
different
it.
tempos all the time. There's obviously a limit to how much you can do. We
Right.
can see that while playing back audio on a video or something. I struggle with over 2x. I can do 2x no problem usually. Um, and you can understand people when they're doing 0.5x. So there's a range of 5. Um,
Or
but
even
at some
slowing it
point,
down, it starts sounding different. Like
right,
I think a lot of people don't like it's unless you've read it or whatever, you wouldn't know that the Inception soundtrack is like the sound of a horn, like a trumpet being like slowed down more and more and
Yeah.
more until it just
Yeah.
sounds like this totally different thing.
what What is that? What is that?
So Inception,
Oh,
the movie, it's about people going
I never saw.
into dreams within
Oh,
dreams and stuff like that. But time keeps slowing down. That's one of the main concepts
uh,
whenever they go into a dream.
mm,
And so Hans Zimmer
interesting.
actually kind of incorporated that into the like soundtrack.
Interesting.
I did not know
All
that.
right. Well,
That's a
Yeah.
cool
yeah.
fun fact.
I think so far we haven't really. I think so far everything works out really well. So maybe you can tell us what parts don't work out well yet.
Yeah, I mean, I haven't run into any like total roadblocks where I would say it's not going to work because of this, but just a lot of still remaining open questions, or at least for me, open questions. But yeah, I can go over maybe this one necessary assumption first, which might be uh, again a source of questions. But so basically that since we don't have a reference frame, we can't store like individual changes at different locations. So instead, the model input needs to refer to the movement of the entire object. So if we have the top of the stapler moving, before we would store like local flow patterns at different locations in a reference frame. We would say the top is moving in this direction and the bottom is moving in this direction and so on. And at different slices in time, there would be different flow patterns at different locations in the reference frame. But now, if we don't have a reference frame, we basically just have.
I like to point out that previously that didn't work because we realized that the directional arrows you're showing there, if I was just looking at a patch of the retina, I wouldn't get those directional arrows because of the, remember, I forget, I don't think we have a word for it, but
Or they were ambiguous. And
they were certainly
that was one
ambiguous, right?
problem. And then the other problem was it
Right.
was hard to actually learn them because
Right.
in any
But
given
they were
moment
seven,
they're all changing.
they
And
were
then
ambiguous, but the most likely
Well,
interpretation of a local patch would often be wrong.
I mean, they're ambiguous in some cases. And if we assume smooth pursuit here, if we were doing smooth pursuit here, we are able to get these flow patterns too.
Well, smooth pursuit is not a problem,
Yeah,
right?
so
Because
I think if we're doing smooth pursuit and getting these from how we're following the
right,
object,
right. Well,
then I don't think
but
there's an issue.
okay, all right, fine. So, but I
Um,
don't think we were considering smooth pursuit before, were we? Or maybe we were. Oh well,
yeah,
maybe sometimes we were. Right.
yeah.
Okay. All right.
But it was more that we would need to observe all of these locations. So like we would basically have to look at the stapler 4 times and follow it here, follow it here, follow it here, follow it here. So it
Right.
would be taking a lot
Yeah.
longer. We would have to observe it many times in many locations to actually learn this model. And yeah, there we also had some workarounds like potentially sharing between columns or just saying that we just observe behaviors many times before we actually learn them. But this would be making the learning part much simpler because we could just observe it once and store all of the whole change of the entire object. Um,
The
so yeah,
problem, there's a problem here, but keep going.
well, yeah, basically, but now that we don't have a reference frame, we only get one input at a time. That input needs to contain all the relevant information. So it needs to contain kind of where that object exists and how it's moving in space. So for example, for the stapler top, we have a bar and it's rotating down and it's further rotating down and further and then it stops. And it also means that the receptive field needs to be much larger to actually detect that whole child object's movement. So it needs to, yeah, be large enough to contain the top of the stapler. Instead of before we were thinking of the receptive field as this kind of smaller patch that detects this local change.
Right.
And just as a second example, if we have this boat moving on this trajectory, before we would again store kind of local flow in a reference frame. Um, and yeah, you could move freely in that reference frame as the boat moves through that behavior and make predictions at any point in any place. But now you need to kind of capture the whole object movement, which in this case is maybe a bit simpler because there's no rotation of the boat. It's just moving in different directions. But still, it seems like you still need to somehow represent the amount of space it occupies. And it makes it a bit more difficult to make a kind of arbitrary movement, like start here and then move down here and predict when you're going to see the boat again. You'd have to kind of simulate the sequence in a temporary reference frame to be able to do that, which is not out of the question, but
Yeah, and actually maybe those
that seems
links that we
okay.
were talking about could help with that because sorry, the links between L4 and L3, because you would know where you are in L6, and that could tell you what to predict in L4, which I guess could be associated with certain states in the sequence. Like somewhere like here, where there's different locations are actually associated with different movements. It's harder if it's like, I don't know, all rotating on one spot, and then it's more ambiguous.
yeah.
So I'm going to make a suggestion here is that perhaps we have to figure out the movement of the entire boat or the entire stapler top. And that might be done in a model-free way. That is, an attention window could be, it feels to me like what you're really trying to observe is the movement of an area, an attended area.
Yeah.
So it doesn't matter if there's a boat or an orange or the squiggly thing moving around here. It
Right,
occupies some area.
Yeah, I was trying to show that here. Like, this is not supposed to be a boat. This is supposed to be like model-free input to layer 3
Okay, right.
of like V1 or something.
So we have an ability. I mean, first of all, there are magnocellular cells that detect motion, and you could easily we could think about the mechanism by which an area would be specified just based on this bottoms up input from the retina that this is the part that's moving. So we need to figure out how this attended area is moving through space. That's the only point I want to make there. I think part of the solution is to have introduce attended areas where we're trying to say within this area, what is the motion, the overall motion. I don't know how to do that yet. I mean, it's like because that attended area can change in size. I haven't spent a lot of time thinking about it, so maybe the answer will not be hard. But somebody, has to say, "Hey, here's an area, and we want to detect the movement of this entire area." It's like independent of the rest of the retina or the rest of the world or something like that. There must be a mechanism for doing this, but I have right at the moment I haven't a clue how this happens. It doesn't bother me. We can figure it out, but it's just it's
Yeah,
not
to me
something we've
the
talked about.
almost harder question is how it would be represented in layer 3 mini columns. Like if we say, I mean, I understand, okay, you
Yeah.
can easily say each mini column corresponds to a movement direction, but then if it also needs to encode the kind of area in space, the attended area in space, then
Well, I
we
don't.
we quickly
Well,
get to the point where we need a lot of mini columns to encompass all the different amounts of area that could be occupied by an
well,
object.
no, well. I'm not sure. I guess I'm confused by that. I wouldn't think so. I mean, in theory, once I have this attended area, all I have to know is that whole area, how it's moving and how its orientation is changing as it moves through some trajectory through space. Right. That the it and that seems to be could be represented by the same mini columns we have now. Um, they just represent movement and direction and orientation, whatever, and it seems like they could do it. Getting the data, forming the mini columns to represent the right thing, it seems to be the hard part.
So you're saying you
Um,
would actually not store the area occupied, you would just store the movement directions?
uh,
Like the
well, that's how
triangles
I
would
was
be part
thinking
of
of
the
it.
model.
That's how I'm thinking about it. Oh, I didn't realize. Oh, you meant the triangles actually represent the area of the boat. I didn't catch that.
Yeah,
Interesting.
right. And like just like with the stapler, I feel
uh,
like you can recognize the moving
okay.
stapler top
Well,
no matter where on the stapler top you fixate.
okay. I hadn't asked myself the question. So my assumption had been, without any thought, my assumption had been that the area is not. It could apply to any area. It is just whatever the attended area is, and so my assumption that it wouldn't be representing the rectangle of the stapler top, but I hadn't thought about it further, uh, because
Yeah.
because I don't know how you'd represent that. That's a morphological structure. We can call it a triangle or a rectangle, but it's still morphological structure. And here we're trying not to have morphological structure. It seems to me the whole purpose of the behavior model is that you can apply this behavioral sequence to any morphological child object or any morphological component. Therefore, you wouldn't want to, as soon as I introduce triangle, rectangle, now I have to have a reference frame. Up to now, I was thinking it's pure movement.
I mean, you
Well,
wouldn't
you
have to have a
orientation
reference
change.
frame, but it would be inefficient and it would be model free, so it wouldn't have like scale invariance or all these other things.
But how would so what I have some primitives, like I do
Yeah, it'd be
rectangles, I
more
do
like
circles, I
a
do triangles.
Like a certain set of
right.
magnocellular cells highlight, okay, yeah, rectangles moving, whereas
Well,
another set of
maybe,
magnocellular cells highlight triangles moving. And
maybe, but I would prefer not.
I agree. I'm just saying, in
Yeah,
principle, you could.
I would prefer to say somebody is going to find a attentional area, which could be any weird shape. It could be a blibbly blob. It doesn't really matter. There's an attended area that's moving, and that can be purely bottoms up model free. And now the goal is to say, okay, how is that blob moving through space? And I could take that trajectory, the learned trajectory, and apply it to any other blob. I could learn the sailboat going around the track, and I could then apply it to, a stapler going around the track. And I'd use the same behavior model to it.
Yeah. Yeah, so that was one of the kind of open questions I put here, like how or whether we would actually represent this area that the movement is occupying. And so I guess if we don't represent that at all, it seems that like then we need another mechanism to assign that behavior to an area on the morphology object.
So
saying on
it
this
is represent.
morphology in this whole area, the behavior is
Let's
occurring.
let's 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 say we do have to represent it. Let's say we're represented by some unknown mechanism we don't have yet called the attended area. All right. So
Well, the
the
attended
shape of
area is more about the input, right? It's not about what's stored in the model.
no, because well, it's okay. So I have this thing called the attended area. It could be bottoms up, meaning I'm just detecting something moving through space and I attend to that area. But it could also be, and so, but I could also say, I'm now going to apply this trajectory to a child object, and I could take the child object and turn it into an attended area. The child occupied the attended area. So,
I mean, well, like if I learned
so I
about
don't
the
know the
stapler
problem.
behavior and it's all just the black arrows, just rotation happening. I still know that on the stapler, if I move on anywhere on these locations, I will see the behavior happening. And it will look a bit different depending on whether I'm here or whether I'm here because the hinge is
Well,
at
no,
the end of
but just a moment ago, we decided we weren't going to try to learn the vector flow patterns like in the left side of this picture. We were
Right,
going to
but
try to
it's
come
still
up.
that's why I'm trying to find out a different way to encode that information of where will I actually expect like to see the stapler top at any point in time? And where does the behavior exist on the stapler?
One could argue. Well, this is where I started having troubles. It's like what you'd want to do is you'd want to be able to say, okay, there's something that's moving. It's it's moving through space, or it's maybe, in this case, it's actually it's just hinging. It's actually rotating on one point. So part of it's moving through space and part of it's not. Um, but it seems like, okay, I want to encode all the types of movements that something can happen. It can translate, it can rotate, or some combination of translation and rotation. And I want to apply that to the entire attended area. And in which case, then I wouldn't have specific flow bits like we're showing on the left panel there.
Yeah.
But I would be able to somehow apply that to a child object. So I could say, what would the child object's position be right now? given that I'm, moving the whole thing, I'm translating and rotating through space, and I'm going to translate and rotate the child object. So where would it be if I applied that translation rotation? I can't get this to work yet, by the way. So this is what I would like it to be. I would like it
Yeah,
to be just this single variable that represents translation and rotation of an entire child object.
yeah, I guess if we assign the rotation to the correct location on the child object, like the hinge part, and then we know, okay, there will be an orientation change around that origin point. Maybe then
But
one
we're trying to
variable.
avoid that, right? We're trying to avoid that idea, this origin points. I mean,
Well,
this
around
is
that
this is the
point on the child object, like
right,
Can we
but
kind of implicitly get location through L4? Since L4 is unique to a specific location,
implicit
with the
location to
representation there.
alpha. But
how would
I'm
that
just thinking
go?
if a certain behavioral, like a certain behavior change, is sort of bound to a unique feature or like a feature at a location in L4, then in some sense it is also bound to the reference frame, but without needing a separate reference frame. Does that make sense? So, and then like when the hinge is full in the fully open position, that's going to be hinge child at a specific location. So that's going to be a unique representation in L4. That's specific to a location. That can be bound to a change happening. And so
I'm
that means
I'm
that
not
that
following how this
change,
solves. I'm not following how this solves the problem, Niels. To me, the problem is, and maybe it does, but I'm not following it. To me, the problem is, can you represent the behavior of an entire object like we're showing in this picture here? Can you represent that with a single set of mini columns?
Yeah.
Not look at individual points. Remember, this is I don't know if you caught
yeah,
the parallel here, but remember when we were trying to figure out how compositional objects work, and for many years we thought it would be something like this: you'd have a child object and you'd specify where it is in its rotation to the parent, and we decided no, you can't do that. It's not going to work, and you actually have to do it on a point by point basis. You have to look at the different points on the child object. We also realized you couldn't look at all the points on the child object. So if the child object wasn't distorted, then you really one point would define the rest of the child object. But in the case where we had a bent logo or a changing logo, you'd have to look at multiple points to see where the changes occurred. This is a similar problem here. We're trying to specify, this is just like a child object. We're trying to specify how this child object is moving. And we'd like to do it with one variable that says, oh, it's here and it's moving this way. But as with compositional objects, we couldn't do that. We ended up having to do a point by point basis and sort of interpolating in between. So I'm wondering if that's the solution here too, is that you could
Well,
observe,
that's kind of what we had before. We would learn the trajectory on a point by point basis. And then now we're removing that. And that's
right,
why
right.
we
But
need to kind of,
remember, we never really worked this out in the compositional model, but you don't really need to learn all the points in the because if the child object it was rigid, like the logo was unchanging, then one point was sufficient to specify all the other points. There's one point would tell you where the logo is and its orientation on the parent. We only need to do more points. Technically, you only because after that you could extrapolate what because that basically then you locked in your child object and you can predict what you'll see. In some sense, the equivalent here, and I don't really understand it. The equivalent here would be I only need to follow one point on this on the moving sailboat, and somehow that would predict all the points on the moving sailboat. This would be the analogy to compositional objects. It'd be like saying, okay, because right, I just need to know one point, and as long as the sailboat is rigid, I can follow that one point through space, and the rest of it. Let's go back to the picture of the stapler you had moving up and down. So what this idea would suggest is that I could observe one point on the stapler going up and down. And assuming that the stapler top is rigid, then, and I apply this to a child object, which is the stapler top, then the trajectory would tell me where all the other points are. It would tell me how, the rest of the stapler top, how it's moving. Did I make that clear, the analogy between compositional objects and this problem right here? Did anyone follow that? You can say no.
I did not follow it.
I was thinking of
Okay.
a related idea. I think
Thank you, Jose.
I guess maybe a potential solution, and I'm sorry I'm jumping to a later slide and it's a bad animation, but one of the those are all supposed to stay on the stapler, but I try to tweak the number of seconds that they take to synchronize with the GIF, and it just wouldn't work. Anyways, you can imagine it. Basically,
I think my brain is trying to learn what this behavior is right now, and it's struggling. It's interesting.
yeah, can you tell me
Okay.
if I need to slow it down or speed it up?
I don't know.
Anyways, the question I was wondering was, well, which point do we need to fixate on the stapler to learn the behavior of the top, and then also can we recognize it on when looking at any of these points or doing smooth pursuit on any of these points? So like which part of the object needs to be fixated on? And I guess one potential solution could be that we have overlapping receptive fields. And if you have these three receptive fields, only the center one would actually be learning the behavior or inferring the behavior. And only the center one, because only that one contains the full stapler top. The other two would kind of the end stop cell or whatever, they would say, oh, it's going out of my receptive field. I'm not going to send up the change. And that way,
No,
yeah.
I disagree. I don't think it's the right assessment. Imagine we have our mug with a logo on it, right? Now, to learn the logo on the mug, excuse me, we have to observe at least one point on the logo coincident with the location on the mug. At least one. And once I've observed one, I can now establish I now know where the logo is. I know its orientation on the mug. I've only learned one point, but once I've observed that point, all the other points in the logo can be predicted. Now, we would typically learn more than one point. I would look over the logo at multiple places, but one is actually sufficient to learn the relationship. I'd have to go back to that point again, perhaps, but one point is sufficient to learn the relationship because the logo is rigid and the cup is rigid. The same thing's happening here with the stapler. I'm arguing that I could observe one point on the stapler top, including the hinge part, because the hinge part was demonstrating behaviors there too. And I could say, okay, at this point, I've observed this behavior, and if I now somehow locate myself on the correct part of the hinge top, I can predict how the rest of the hinge top will move. Because it's I don't know how to other than describe it. It's very analogous to learning a point on the logo in the cup. But here we're doing the exact same thing here. We're basically defining a child object on the stapler, but the child object is moving. So
But I see how one point is enough, but I
Yeah.
don't see how you would do more than one point since you don't have a reference frame. How would you incorporate a second point?
good question. So this is why this falls apart because what we want this is the problem. This is exactly where I got stuck yesterday. It was like saying, okay, on the one hand, I want it to be like I would want to just have one variable says, here's the stapler top and here's its orientation. But on the other hand, it seems to me I need to know where I observed it on the object, and that makes a difference. And so it seems like, I don't know, I'm at an impasse there about it. Maybe what Neil said earlier would help somehow, that which I didn't follow, but sort of bringing back
Yeah,
in
I don't know if it totally
bringing back in
resolves it, but
reference
yeah, just
frame
trying to,
information.
right.
Anyway,
I guess
this to
you
me
could
was
maybe if you say, okay, if I fixate in the middle or at the top at the bottom, we actually observe different um, movements in the reference frame. And so maybe we could learn three similar trajectories, but slightly different trajectories, and associate them with the locations on the morphology model.
all right. So you're saying these are actually three different trajectories I've learned, and they're associated with different points on
Yeah,
the morphology
maybe.
model. That
Uh,
that makes sense. That makes a lot of sense.
and maybe one of them is
Um,
already enough to do a lot of things, and it's not going to capture everything, but uh,
that is right. That seems right to me. So that's basically saying I don't have a single trajectory that I've learned for the stapler top. I could have one, but if I track different parts of the stapler top, I'll learn multiple trajectories. Each one will be associated with a different physical location on the stapler. Um,
yeah.
that does
Um,
make
and then
sense to
again,
me.
but then yeah, do we want to maybe bind it somehow to locations if they're associated with different locations?
So you would
Right, like
associate with a location on the morphology model, which has a reference frame. I don't know if that's what you were referring to earlier, Neil said.
Yeah, it was more like how that might work anatomically. I was just thinking if L3 doesn't associate with L6, it could kind of indirectly via L4.
I mean, we could even do it compositionally, that it becomes an input to the next higher column, and we associate it with the parent morphology there.
oh, you lost
Yeah.
me on that one.
Either way,
Can
somehow
I
we
just
could
bring up
associate. Yeah.
um so the problem here is we don't really want to have four separate trajectories learned, because we can learn a different trajectory for every point along the stapler top. And each of those trajectories are not tied together at this point in time. They're just like, oh, if I'm on this point, I observe a behavior, but if I'm on a different point in the stapler top, I observe a different behavior. And they're not in any way combined in any way. They're just sort of independent at this point. They're just four separate trajectories that are learned in 3B. Um, it doesn't seem right. Um,
I mean, there would be
I don't
I don't
see.
quite
think.
similar trajectories, so you could you could do a good amount of generalization if you didn't store many points by just looking at the one nearby. But yeah, I agree. It doesn't seem super elegant.
No, it doesn't. Um,
Maybe we can pause the animation sometimes. I have a hard time just not staring at
yeah.
it. It's
Thank you, Scott. Good
yeah.
suggestion.
I mean, it's good.
Can you? I mean,
Especially
that's a
because
good
the more you
picture.
study it, the more you realize how weird it is. Like the stapler kind of moves down and then it sort of like hops up. And I think that maybe been part of the syncing issues you had, Vivian, is it's not a smooth movement.
Yeah, yeah, I tried
The
like
thing that
the
bothers me
smooth start,
is that
smooth end.
you have two top. There's two parts of the top of the stapler. There's like the outer casing, and then there's like the metal part underneath it. And one is forming an arc, and the other is moving just straight up and down. So that doesn't physically. I don't think it's possible. It's like it drives me crazy. Um, well, it's physically possible, but that's not the way staplers work. Well, okay, so I think, I mean, let's sit back and say we have an issue we haven't resolved. Um, we have a mechanism for learning trajectories. It seems like on a the latest suggestion was, hey, well, we could learn different trajectories for different points along this moving thing, but that doesn't seem very efficient. Um, it
Well,
could work,
hopefully we'd
but
only learn new trajectories if they exist. Like anytime we create new representations, like it's only if we're failing to predict what we're observing. So
right,
it feels like,
you know,
you know, for a simple object like a stapler, maybe one trajectory would be enough, or two or something, but we wouldn't learn like, I don't know, thousands for every
Yeah.
single point along the arm.
Right. You wouldn't want to, at least.
Yeah.
I mean, I
Yeah,
still
but so,
think
so
it.
like a simple heuristic of like, am I predicting what I'm seeing? If so, I don't need to form new synapses to represent it. Uh, Feels like it could help with that at least.
Yeah, I mean, I still think it could be a valid option to say that if the child object isn't completely contained in the receptive field, we won't learn the behavior in that column, and and we won't recognize it in that column, and that way we always just learn and infer the behavior in the column
But
that covers
but
the
what but
child
what
object
but what columns? We don't have columns that hold the entire child object. What
when
column?
we
Where are
need
those
to.
We
columns?
do a movement, don't we? I thought that was
Yeah,
the
I
proposal.
mean, the receptive
What's that?
field input needs to cover the whole child object.
But but is this the attention area you're talking about?
Well, yeah, I mean, sorry to go back to animations, but the what I showed on here, like before we thought about the receptive field being a small feature on the object, and that would still be kind of how we think about the layer 4 input, but layer 3 input would need to be covering the whole area of
All
the
right.
object.
So to me, I wouldn't call. I mean, to me, this is not the receptive field of a cell. This is the attended area. There's like somehow we have to bring in attended areas. An attended area is sort of like a receptive field, right? It's kind of like one. Maybe that's the walk away from today. And to me, I feel like we have to introduce the idea of attended fields, attended areas.
And
I
they
know we
can,
have them,
and
right?
the
And
attended
so,
area can be larger than the receptive field of that
of
column.
course, it has to be, right? Totally. In some sense, it's like a made up a receptive field. It's like, yeah, I want to recognize the thing in this area and its behavior in this area, which should be essentially much larger than the classic receptive field of a cell.
Well, I mean, before when I
How,
thought about attended areas, I thought, okay, it can be large and it can vary in size at any point in time, but it basically gates which columns are getting input, not that one column gets
right.
all
Well,
the
that
input
was
from the attended
right,
area.
right. Well, that was sort of a first thought that makes sense, but then the idea that we were trying to determine the movement of the entire area, right? Which for the behavior, we wanted the movement of the entire um, we wanted the flow of that entire area, how that entire area is moving, which you're showing with the circle around the ship. Um, that means that I have to do more than just restrict the input. I need to somehow process all the input as if it was a single receptive field. It's like I want to
So
take all that and run it through the spatial pooler.
what if the first pass is sending to, so you've got some larger region, it goes to the cortical columns in the sort that belong to that region, and through lateral communication between those columns is how each individual column gets some information about wider spatial areas. That makes
What
sense?
Say
what
that
what
again.
what are you no, Scott? What are you proposing? A mechanism for the tended area, or what are you proposing here?
Yeah, a way for an individual column, which has a limited receptive field, to
Hmm.
gain context about a wider area, like a
Okay.
wider attended region.
You mean kind of like
By
almost like voting, but in L4 or like L. I guess
Yeah,
this would be
or higher,
L3V.
or L3, yeah, because of the
So what is
propensity
your
for
idea
lateral
specifically?
connections. The idea
So what's the idea?
specifically is that if there's a wider attended region that to be attended to, let's say a big masked area,
Yeah.
uh, all the columns associated with that area get activated.
Hmm.
And then through lateral communication, each one individually gets information about which neighboring columns are being activated. And so in that way, it's able to, each individual column, which has limited receptive field, can gain information about a larger
Right.
area
Right.
that's being excited.
So okay. I like the general idea, although they gain information is pretty open ended. Um,
Mhm.
It's like,
Yeah.
one of the, I'll tell you an idea I've been noodling on every once in a while. Is we have this idea of a cortical column, and in the cortical column it has its own reference frame, and everything's isolated in the column. But then already we already broke out of this because we assumed that the movement command coming into the column, like the movement of the whole retina, is not a small receptive field. It's a very large receptive field. So the movement vector coming into layer 6 to update the grid cells is really the entire retina. It's like this very large pattern on the retina. So it's okay. Well, it's not being isolated to one little like receptive field here. We already have this very large thing coming into layer 6. And then I was noodling on some other ideas well, how, how, okay, so we basically a grid cell is going to be made up of a bunch of these repeating grid cell units, and they anchor differently. So, like, there might be 6 grid cell modules. If you think about the tank paper, you can picture that. It had 6 grid cell modules, and they all anchored together. But what if they anchored further? Like, what if multiple columns, the grid cells could dynamically anchor together or not anchor together? Meaning, I could take a section of cortex and force them all to be representing one reference frame, just by forcing them to anchor together. Like I'm already going to force 6 of them to anchor together. That's from the tank paper, the 6 repeated modules that anchor together. What if I could now anchor 12 or 15 or 100 of them anchor together? They would, in some sense, they would be representing one larger reference frame for that set of columns. Now, this is a very fuzzy idea, so I'm not going to be able to go much further than it. But the point is, I was trying to think of what kind of dynamic mechanisms could exist that would change the receptive field of an area of cortex to meet the sort of idea that came up in Milan, which was that, we wanted to detect the movement over a larger area. And so this is like one of the ideas I came up with. You could dynamically change how grid cells anchor together, and therefore they become like one big receptive field and one big monster column. And maybe the spatial pool would work differently too, or something like that. These are very fuzzy.
Yeah,
You know,
when I was thinking about like the movement of the child object, uh, I agree. Yeah, we could have different size receptive fields going into layer 6 and layer 4 and layer 3. But I was still thinking of them as fixed size receptive fields. So if you have an attentional area that can change in size at any point in time, I can't imagine how the spatial pooler would be able to learn for any
I don't
size
know either.
touch. Uh,
I don't know either. And so
Yeah.
right,
The physical wiring would be an upper bound on what can be
right.
attended to.
Well, right, but I think there's something like this going on. There's something going on which I know that the attentional fields have to work. We keep coming up with this idea that somehow, like, oh, I want to recognize even a spatial pattern in this area that's bigger than my classic receptive field, or I want to recognize the motion of this area which is larger than my receptive field. And it needs to be dynamic. I have to specify the size of the receptive field to do that with, because the attention area is dynamic. It can be here, it can be here, it can be big, it can be small. So,
But in principle, there's nothing to say that you couldn't have like parvocellular cells going into L4 come from a smaller region of the retina. Magnocellular cells going to L3 and L6 come from larger areas. And within those fixed receptive fields, we can dynamically shrink or grow attention, but only up to the total size of one of those receptive fields.
right, but you could,
I'm not
but
saying that necessarily covers everything we want, but at
I
least
don't,
it covers the
yeah,
basics of it.
it doesn't seem right to me. It just doesn't seem right. It feels like I need a mechanism which is somehow more dynamic. I mean,
If it's that dynamic,
what?
it seems like it would have to either, like how Scott said, either you could rely on voting on different spatial areas by giving different columns input, or you would have to do it kind of model free before anything goes. It's hard for me to imagine that we could have physical connectivity from all parts of the retina to every column and then gate that somehow
Right,
to an attentional area.
right. Well, this is why I mentioned the grid cell idea. It's just an idea. I mean, and it's just exploring it because that didn't seem to require a lot of new wiring. It basically said, I'm already decided to anchor 6 grid cell modules together. I'm thinking about the tank paper. Within one column in the tank paper, this is an entorhinal cortex, one column equivalent. There were 6 of these modules that were sort of tracking each other, and they're all anchored together. And then presumably just right next to it, there's another bunch of grid cell modules and they're anchored separately. But well, why couldn't they just, it seems anchoring more grid cell modules together would be something relatively simple to do. Not like it doesn't require a lot of learning. Um, it would be a non-learned mechanism in some sense, so it doesn't require a lot. So there's an algorithm that would potentially say, oh, I have 10 columns that now act independently, but now I'm going to make them act as one.
But
And they're all going to share a reference frame.
how would sharing the reference frame help with detecting more global like flow in a
I don't know
larger
yet.
field?
I don't know yet. My point is, it's just, I'm trying to imagine mechanisms that would allow me to process an attended area as if I had a receptive field that was just for that attended area.
Yeah, so a
I mean,
similar mechanism basically for layer 3, but without a reference frame or
yeah, I have really, I mean, I'm just going to state it that way again. We kind of assume that we have these fixed receptive field properties and sizes. And whatever I keep thinking about attended fields, I want to treat them as a new receptive field, attended field. Like I want to do the same things I normally do, but I want to do it on this area, a bigger area. And
I have
so I,
one
I
idea.
mentioned yeah, go ahead, Jane.
So let's say we have a bunch of LMs called like in hierarchy. So from the hippocampus, which has the largest receptive field, let's say you're looking at the whole intersection and you see a car passing by, within the receptive field of the hippocampus, only a part of that will have some flow, like optic flow, because a car is moving by. And that specifies the attentional region. And any columns, any like smaller columns lower than the hippocampus that are in that region can say, okay, look, the hippocampus is telling me this is the attentional region, so I'm going to learn the behavior. And it's going to be the same behavior because it's like all within the same attentional region.
Well, a couple of things you said there. First of all, the assumption that the receptive fields of the cells in the hippocampus are the entire visual field, for example. I don't know if that's true. Maybe
Yeah,
it's true. I don't know.
yeah.
But
But
let's
well,
start with
I guess I'm
that.
assuming that
That
yeah,
let's
that there
let's
is
just let's
at
just
some
start.
higher level, yeah, that there's some higher level that encompasses the whole
So,
um
all right. So I
thing
mean,
that it
Niels, I think
makes.
Niels would keep bringing this up idea similar in the past. Like, oh, as you go up the hierarchy, we have these larger and larger receptive fields, and they encompass everything. So maybe you're saying go right up to the hippocampus, maybe incorporating everything. And then you're saying, well, it detects motion within some subset of that, and that becomes the attended field. So maybe you're saying the attentional space originates in the hippocampus, something like that.
Yeah,
Um,
like
okay.
the higher
Um,
column will specify the irregular attentional. So the way that I'm thinking about receptive field is like this receptive field I'm thinking about like as a circle that Vivian drew, while the attentional region is whatever shape of the object that we're attending to. So it could be a stapler top or look irregular, whatever irregularly shaped object or child object. And that irregularly shaped attentional region can be specified by which points in the larger receptive field where motion is happening.
right. So I think that sounds right. Although it sounds believable, but does that answer the question of how we uh, perceive the motion of that entire attended area, or uh,
Well, at least you can specify like, okay, U columns that are in this motion area, the attentional area, like you're gonna be all learning the same behavior. Yeah.
Something
Is the
about
problem with the
something
small
about
receptive? Yeah. Go ahead.
let's talk about attention areas, for example. I have a whole bunch of notes about them. One of the things is that often, like if I could be looking at you, OJ, and then something moves to my right, like an animal in the bushes or something, right? Um, I have a I'm going to attend to that area, and I'm going to attend to it immediately. Like I know where it is off. I know how far away it is and what direction it's in. And my brain will start even before I move my eyes there. It'll see if it can recognize whatever's there. I mean, it could be very poor because I have very poor resolution over the side. But my point is, the point of mentioning this is the attended area is not really relative to the retina; it's relative to the body in this case, at least. So it exists sort of independent of individual columns. It exists in a body-centric representation. It has nothing to do with which columns are working where. It's out there in some space, and now I can turn my head and look at it. That doesn't change where the attended area is. The attended area is still there, still in the same spot. Well, now it's in the middle of my retina. Before it was on the side of my retina. Um, so I only mention this because I don't think the attentional area can be defined in terms of receptive fields of sensory columns. I mean, it could be derived from them, right? My sensory columns detect there was motion in some space over here to the right. Um, but the definition of the attended area has to somehow exist um, independent of that. It's like it's out there on its own, and now I'm going to move my sensors to the attended area to see if I can see what's in there. Um, so I think when we
And
think
so
about
there might,
attended areas,
yeah.
we can't define them in terms of receptor fields. They have to be defined in terms of space, egocentric space, seems to me.
Is the attended area object centric, as in, is it a whole object or is it volume regardless? Like, could it be have an object and have another object in the same attended area, or
Well,
do we
I
always
think
attend?
initially, well, I don't know, Rami. I think in the example I just gave, you wouldn't know yet, right? Because you might be detecting part of an animal moving through the bushes, and part of it is obscured, and part of it isn't.
But you're not
So
attending
you
to both at the same time. You're attending to the animal. It's just it's
no,
obscured. You
no. I'm
don't
attending
change.
to where the movement occurred. I'm attending to where the movement occurred in the world, and that movement may be a part of an animal, or maybe the whole animal. I don't know yet. It'd be partially obscured. So,
Hmm.
but I can't know anything about the parts that obscured. So basically, I'm attending to the part of the world that changed, and
Yeah,
I
I,
don't know
I
yet.
think
But I
there's
think
some
it,
research from like the crowding literature and stuff, where like, yeah, you can attend to kind of larger areas, but the more that there's sort of interference between the objects within that area, the more you get kind of confused about what you're seeing. So as in, um, I don't know, I'm looking at a desk right now and there's a keyboard and a mouse and this like bright yellow cable, and I can kind of sort of attend to a larger area and sort of think about all those at the same time. But if there was three different cables that are all quite similar, what I'm actually seeing is going to be much harder to kind of mentally represent because there's similarity in those. Um,
Are you
I
sure
don't know,
that's
which I guess
attended?
just say fairly flexible,
I'm not sure
but
that's those are attended areas, and I'm not sure what the relationship of that and attended areas are. Um, it's not clear to
yeah,
me.
can I share like a quick 1 minute video that
Sure.
yeah, look, I feel like this for me, I feel like attentional area is like I'm not sure if it's object centric, but you're definitely focusing on the object regardless of what's happening kind of
Like
outside.
attended areas are both top down and bottom up. From a bottom up point of view,
Yes.
it's not objects. Bottom up, it's just detected motion occurring someplace, and you're
Right.
going. That becomes the area you're going to attend to. Tops down, it's going to be, something specified by the cortex, and
Yeah.
that could have a more specific shape to it. You know.
yeah. And I guess
Right.
my point
So
was just
maybe
that I think sometimes it can contain multiple objects, but but that there are
Right.
potential limits to that. It's not like a
I don't
perfect.
know. You know,
It's
well, I
harder
don't think
generally when there's more objects involved.
I think the way I've been thinking about it, with you in a second, OJ, but the way I've been thinking
yeah.
about it, essentially with the attended object, it's like child objects and so on. You just really the attended area, you're trying to recognize a single thing in that attended area. Like a region only recognizes one thing at a time. So you're trying to recognize it could be a compositional object, but you're trying to infer one thing in that space. And if it looks like there's more than one thing in that space, then you have to infer them separately. Maybe there's 3 animals in the bushes over there, and I have to look, oh, there's 1, there's 2, there's 3, as opposed to 1 animal. Anyway, this is interesting. What are we gonna watch, I think?
I'm going to actually, like, this is going to be like an interactive thing. And I was thinking about this yesterday. So in this video, I'm going to give you a task, which is to count. There's a basketball game happening here, and you want to see how many basketballs went through the hoop.
I think
So
we
you
I
want to
think
count
this might
them.
be too well known.
Okay. Okay, yeah, this might be too long. Okay, so if you haven't done this, okay, all right. So everybody knows.
Well, I know the one
the
where they pass it back and forth. I don't know the ones through the hoop, but it might be the same.
Yeah,
Oh,
count how
it
many
is
times the
passing. Yes,
players.
it's a pass.
Okay,
Yes,
never mind.
has everyone seen this? Has
Yeah,
anyone
I
not
think
seen it?
it's too famous.
Yeah. Well, that's just right. It's amazing. It's of course it's actually when I'm seeing it's not smooth, so it wouldn't work as well, I think.
I thought it was the hoops things, but yeah.
No, it's a passing of it, but it's not working for me because it's not smooth. It's when I'm
I see.
visiting. Right. Well, it
Oh,
just
it's
shows
not
you that
like
you're attending. It's a good example, right? Because
It'd be funny.
you're attending to something that's moving, which makes it easier, right? You're just trying to follow that movement thing, and it really does show you how little else you see that's going on in the picture.
Yeah.
This is pretty model-based effect, I think, because we know to look for the basketball. So
Right.
there's plenty of other.
But my point is, it's just a circle, really, and the point, and normally it's like you're moving, right? It's moving. So, well, anyway, it's a moving thing. It's easier to track it.
Someone should create a new version of that where there's like, I don't know, like a baby giraffe that walks along the bottom. And everyone's gonna be like, oh yeah, this is the gorilla video, blah blah blah. And then it'll be like, but did you see the baby giraffe?
Yeah. Well, the funny because the
How about it's
gorilla is a
all
very
apes passing the ball and then a real human walks through this?
the gorilla works well because there's very little hardly no frequency components in that gorilla outfit. It's like a
Yeah.
big black blob. And I think even if a giraffe walked across instead of a gorilla, you would notice it. I think it's they chose the gorilla outfit wisely.
So maybe the attention region is determined like both by the motion of the optic flow, but we can also decide whether we want to pay attention to it. And if that is the case, then we can say like, okay, like lower columns, like now you can learn the
Well,
behavior.
this clearly we don't know how the ball is going to behave in this case, so you're tracking it based on bottoms up input.
Right.
But it's also top down. But other top down behavior things, I remember attentional things. I've talked about the idea that you can have a complex scene and flash it in front of your eyes, and you recognize what the scene is. But then I say, what was in this corner on the left over here, and you don't know. And then I say, well, fixate in the center of the screen, but attend to this rectangular area. So you're fixing in the center of the screen, not looking at the attended area, but there's an attended area off the side, like a rectangle at some angle. And you don't move your eyes from the fixation point, and yet when the image flashes up, you can recognize exactly what's in that rectangle, where before you didn't see it. So like, I don't know, it's just another example where you can have like a top-down attended area, and normally you wouldn't see what's in that attended area, but now that you're attending to it, you do see what's in the attended area. Anyway, I think, to me, I don't know, this is a fun topic to talk about because I keep saying over and over again every week, we have to figure out how attention works. So, it's it's good to talk about the issues. So again, I'm gonna try to suggest something. I'm gonna suggest, okay, you have this idea of attended area. It is not based on receptive field sizes. It has to be independent of that. It exists. It's specified in sort of egocentric coordinates or something like that. It's coordinates that are, and it can be bottoms up or top down. And in some sense, what we want to do is we want to infer whatever objects in that space, and we also want to infer the behavior of the object in that space. And there's an open question. We still have the open question about how do you infer the object in that space, the behavior of the object in that space, if you're not attending to different locations in a reference frame.
I had maybe a kind of related open question. I don't know if this is already kind of in your list, Vivian.
But
But I
maybe
just
I'll
thought I'd bring it
take
up,
your point.
which is okay. Just in
You
terms
had a
of
lot
like
more. You had a lot more slides, didn't you, Vivian?
A few.
just in terms of
You should
like
go.
if we're assuming we're doing smooth pursuit, and so let's say we're following the stapler top, just thinking about exactly how we are getting movement information into L3, because typically when we talked about object behaviors in the past, yeah, sometimes we included smooth pursuit, but generally we talked about like optic flow happening, which is or flow
Right.
on the skin, which is simpler to imagine. Um,
I see
so
where you're
yeah,
going.
it feels like it's
If we're
almost more
following it,
similar.
if we're
Okay.
following it, there's no optic flow, right? Or
Yeah, exactly. At least
well,
locally, there's no optic flow,
there's
and so
no
it
optic
feels
flow of
more
the
like
thing
a
we're
motor efference
tracking.
copy that's going into
It's
L6.
well, maybe there
Um,
is optic flow. The optic flow is not the object, but it's the stuff around the object.
yeah, right. Um,
That's a good
but then,
observation.
but then it's a bit weirder with like somatosensory, because then you might even get less. Like then you don't necessarily like you might get a little bit of movement. I don't know as you move your hand on it. Like let's say you're lifting the stapler top, but but you wouldn't necessarily feel that much movement. Um, but I don't know. It was just I thought it'd be worth kind of talking about a bit. But
No, I think it's a good observation. Is that the information that's coming to layer 3B, at least on the visual side, is we originally the original behavioral models, we assumed, oh, you're fixating some point and something moves to your fixation point, therefore you have this flow pattern. That's what we're going to detect. But if you're doing optic flow, as you point out, that's not what's happening really at all. It's really you're just the trajectory is based on, as you said, like an efference copy of the motor command or something like that, or it's the background flow pattern around that
yeah,
thing.
or like a bit of both or
Um,
something. Because yeah, at
Yeah,
least
probably
with your
both.
hand, it
right.
feels like you almost have to rely on like I mean, especially if I'm just like let's say I'm holding it here and then I kind of lift it up, I'll feel like a bit of like a
Yeah.
spinning sensation on my finger pads. But otherwise, my sense that the whole object is moving is mostly derived from the fact that I'm moving it and I'm not
Right. Right.
experiencing that much flow on my finger pads. Otherwise, I would
It's
assume
funny.
that my fingers are moving and the object isn't.
I thought, I was using the opposite example of the finger. I was saying, oh, you're moving your finger and sliding along the edge of the rim of a cup, something like that, where you do feel the flow. Um,
Right.
um, I think that's a really good observation, is because now you've sort of opened up the idea that we have to think carefully about what are we actually detecting. Is the object moving, or is the background flow moving? It may not be hard to manage this, but I think at least I was sloppy in the past thinking about that. I wasn't being precise. I think we have to be more precise about what's actually being observed and what the sensors can pick up and where's the information coming from.
It's really
Yeah.
interesting. I think about like the stapler example and using your arm. Like if your hand is fixed to the stapler, you're not gaining any morphological information. It's only behavioral information when that thing is moving. Unless your finger is actually moving along the stapler, that's when you gain morphological information. But when it's fixed to the stapler and the stapler's moving, then you're gaining only behavioral information.
Well,
Right.
another way to
Kind of
say
an
that, Scott,
interesting.
is like if I was grabbing the top of the stapler and I lifted it up, I wouldn't know if I'm lifting the whole stapler or if the stapler is rotating to the bottom. Is that
Right.
another saying that? Yeah.
One
Yeah.
thing
I mean,
this just
obviously,
reminds me
And
actually. Oh, sorry.
kind of the
well,
same
we
with
do
the
a lot of this.
visual smooth
We do a
pursuit
lot of this
too.
visually, right? We learn right. We do a lot of it visually.
One thing this reminds me, I can go back and maybe find the paper later, but when I was looking at the literature for the heterarchy paper, I was going through the old studies from the 2019 Numenta papers where you talked about like L6 motor input from like motor cortex and stuff. And I seem to remember those papers talked a lot about motor input to L3, like as in from motor cortex, which I remember
Is that
thinking was
right?
weird at the time. But maybe that could be
I
like
don't remember
complementary
that.
information. But I
What
can see if that's true
what
or I'm hallucinating that.
motor cortex
But
projects to visual cortex layer 3? Is that what you're saying?
yeah, something like that. It was
Wow, I
like
don't remember
L6
that.
and L3.
Huh. I don't know. I don't remember that. If you could find it,
I'll
but
see if I can find that again.
if it's something poignant point. Vivian, you have more slides you want to present?
If you're up for it, more
Sure.
questions.
Well, I
Uh,
think we want to get all the questions on the table. That's the way we solve these
yeah.
problems, right?
So I didn't mention this, but it came up earlier already, which is, can we use the spatial pooler to learn the most common movements? So not just directional movement, but also rotations and more complex movements, or even change in features. And it sounded like, yeah, we think we could do that.
It could do
That's what
that,
it's about.
but it could only do that if you have enough mini columns and
Yeah.
they're not representing something else.
Yeah. So yeah,
But
just for the most common
the-
ones.
theoretically, you could, right?
Yeah. Then yeah, this one
By
we
the way,
kind of
Tristan, sorry, did you have a question or comment, or was it already
Oh,
addressed?
no, never mind.
Okay.
um we got this one. This may be a smaller one, but just whether there would be in the sequence also kind of an end or stop moving state, which yeah, I think we talked briefly about in Milan as well, that this would be useful for associating behavior sequences with morphologies, because then at this point, this is when the static morphology would be represented or should be invoked, kind of the start and end state in a sequence. But
It
this
doesn't
is,
have to. It doesn't have to stay active for long. I mean, couldn't it just be? You can still make the association with layer 4.
well,
Well,
if they
I guess
all
I don't
just,
know.
if they just represent the moving things, then if there's nothing moving, we can't
Well, okay,
associate it
so
with.
uh, give it a little bit of hysteresis. Say it stays active for half a second. that would that that would solve that problem, wouldn't it? I mean, I don't like the idea
Uh,
of introducing a new like state here. Like, oh, this is the end position state. I
yeah,
don't
we
really
can
like
talk
that.
about it another time. I don't think remembering would help, but more like, oh, the movement just stopped. There's also a certain kind of change, but yeah. Um,
Hmm.
it's not the most relevant open question, so maybe I'll
Okay.
talk about that another time. Yeah, this one we talked a bit about last week already, which is, do learning and inference require smooth pursuit, or could we also do inference without smooth pursuit, for example?
This is learning and inference of behavior models, right?
Right. So yeah, I think learning we said, okay, we want to do smooth pursuit for sure, but then inference, can we do inference by doing a saccade between like from here to here and predict we should see the boat now,
Hmm.
kind of
Hmm.
thing. And yeah, I think we talked a bit about it last week. And it seems like we could kind of simulate playing out the behavioral sequence during inference.
Yeah, that's like
But
saying, what's the 6th letter in the alphabet, right? Or the 10th letter in the alphabet, right?
yeah,
You basically got to go through the sequence to get there.
yeah. But then in this case, it would require kind of a temporary reference frame, like in hippocampus or something, to actually lay down the simulated movements to integrate them together to know where to expect the boat.
Or I don't know if it needs a reference frame. You just need some place where you can imagine the behavioral sequence playing out without actually generating behavior, right?
Well, yeah, but I thought that would need a reference frame if it's about movements playing out. Like you
Well,
need to combine them all.
okay, well, it would be, um, well, okay, in the same ways that we would predict how the stapler moves through time, the space, you would have to imagine the stapler moving through time, right? It's the same mechanism, I think.
Yeah, like
We
you'd
have to
need
get,
to,
you'd have to imagine all this.
yeah, like you'd need to string together this the sequence of movements. You'd have to kind of glue them together to know where to saccade to see the boat a few seconds onward. And yeah, this one, which part of the object do we need to fixate on during smooth pursuit, which I think is still an open question, I guess. But we talked about it. And then this one you are also already brought up, Jeff, about where would the object ID be represented if we now have behavioral states in layer 3. And yeah, you mentioned you read a paper that it could be layer 3.
That paper I mentioned to you, the paper I mentioned to you yesterday.
Yeah, I didn't get to reading it yet.
I have it if you want me to share it. I highlighted a few spots, but it's not
Sure.
definitive, but it's suggestive. And I'll show you where it was here. Let me get rid of the stupid thing here. This paper, you can all see that.
Yeah.
Yeah.
I wasn't really good about making my comments here. So I'll just have to quickly scan and see what it had a bunch of, it's about auditory cortex mostly, in rats. So it's not, but it had a lot of, they were trying to classify how many different layers there are in layer 2, 3. And they came up with ways of basically saying, oh, this layer 3A. Can you see my cursor here? There's
Yeah.
layer
Yeah.
3A and 3B, and then layer 2 can be divided into these 4 different layers. It's all questionable a bit. But here's the other highlighted things here. At first, they tried to divide it into 2 basic categories, layer 2 and layer 3. And then later they broke it down, subdivided. So here they're just talking about 2 basic categories. Maybe it says, so layer 3 cells also received more exciting input for the upper layer 5. So basically this is saying that layer 3 and layer 5 are connected together. These are the, this is what we would expect, right? We would expect that layer 3 could drive behavior and 5 would also, it would go both ways. So okay, here in this section right here, they're sort of starting to subdivide layer 3. So it says cells that receive excitatory input from layer 4. This would be the sort of connecting features to behavioral states. Be localized in the lower layer 2, 3 cells. Be localized in the lower layers did not receive. Cells that receive excitatory input, layer 4 input tend to be localized in the lower layer 2 cells. And cells. So they're basically, this is suggesting that the lowest cells get the layer 4 input. I'll skip that one. I think
Layer 3 further separates into 2 subgroups.
Cells that receiving the least layer 4 input were located more superficially in layer 2. So layer 2 didn't seem to be playing a role in temporal pooling or sequence memory. They were talking about this idea that some cells had received broader input across columns than others. So that was a clue. Okay, so here we go. The cell located in the deepest layer 3, so they call it layer 3B, had the least percentage of input originating from layer 2, 3 itself, but much more inputs from layer 4. So this is, again, suggesting the layer 4 projects to layer 3B, and that would be, again, suggesting 3B is the sequence memory. And then it says that the layer 3A cells, which didn't get a lot of input from layer 4, had more, approximately double the amount of layer 2, 3 input and less than 4. So it's like those are more, the layer 3A would be more like our voting cells in some sense. They're like they're more highly interconnected and they don't really get input. They're more highly interconnected. Maybe I should have prepared for that. I didn't really prepare for this. Let me just go down to here. This is a picture which is a little suggestive. It says, oh, look, these layer 3 B cells are getting input from layer 4 and layer 5, 6. These 3 B cells would be our sequence memory, and the layer 3A cells and layer 2 cells did you not get these inputs? And so,
I mean, would they be this? Would the first ones be the sequence memory, or those would be the ones that pool over L4 to give us object ID?
all right, now I'm going the same thing there.
Because we kind of need L4 input to pool over.
Right, somewhere in here that's supporting that idea. Let's see if I can find it.
Whereas I guess the recurrent activity you were just talking about in L3A, that could be for sequence memory.
Let me see if I can find it. Yes, I know, I agree with you. All right. I shouldn't have brought up this paper because I read it last night, late at night, and I said, "Oh, this is good." And I'm reading here. I'm going, "What the hell?" I'm confused. All right. Well, I can say the following: there are sublaminar. They argue there's sublaminar layer 3 and sublaminar layer 2. They show they have differences in connectivity. Some of these connectivity differences reflect correctly match up what our thinking is here. Some of them are not so clear that they do. How about I leave it at that? And I'd have to read this paper again to make more correct assumptions about it. But I
Can you
think
share?
it's
Because there was a surprising thing about like layer 3 to layer 6 connection, and we said that the behavioral model, gosh, it was one of the highlights. Scroll down below the heat map. More. So, more. Sorry, scroll down more. Yeah. So L3, I'm looking at the last highlight on the bottom. L3 cells located deepest in L3. Even more.
down here. Yeah.
Yeah. There we go. Okay.
The least percentage of input originating from input, more inputs from layer
Yeah.
4.
And then the next highlight says excitatory input from L6 to L3B cells originate much more restricted time topic than L6. Okay, never mind.
So some of
So it's
these,
L3Bs.
they were saying
Yeah,
that
so that's still
some
on
of these
morphological
cells had
models.
some, when they say more has something more restricted topic areas or less restricted topic areas, you might think of the less restricted tonic. I mean, the broader, if it's getting input from the tonotopy is like it's linear on the auditory cortex. So if it's getting broader info, it would be more like a pooling neuron. Be like it's going across columns, something like that.
Gotcha.
That's how I
Yeah.
read that.
Okay. Yeah, never mind. Yeah.
I'm sorry about that. I should have brought this up. Anyway, if you want to read this paper, I sent it to Vivian yesterday. This is it here. Anyway, it's obviously these people are using techniques which are very imperfect for our purposes. They're measuring things which are really non-functional things or very minimal function, and they're mostly laminar, connections and some sort of physiological properties occasionally. But it does tell you that there's a lot of what made me feel comfortable is saying, oh, we can have multiple layers here doing different things. And some of these things that they pointed out fit well with um, um, our our basic theories. But there's also going to be a lot of other stuff going on where it's a lot of noise in here that doesn't make noise in the terms of not incorrect data, but it's like the data they're reporting is noisy relative to what we need to know. It's not a great correlation between what they're measuring and what we need to want to know. Anyway, so I hope that wasn't too much of a distraction.
No, yeah, I mean, yes, definitely good to know that there are a lot of sub layers. And yeah, I also read another layer 2-3 paper recently that also there are definitely a lot of sub layers, and it's I'm not sure why people always group layer two and three together, because at least two and three seem to be quite different in where they get their input from. I mean, sure, maybe 3A and 3B and 2A A and 2A B maybe it could be grouped, but yeah, it's strange that they always lump together.
Right. I think some of the problem is a lot of the cells, like in layer two, they can't easily characterize what they do. I mean, like you give the animal a, they show them a sinusoidal grading and they get great responses in layer 3B and layer four, and they say, "Oh, great, well, let's do that," and then they go up to layer two and it's like, well, I don't know what these cells are doing. They kind of fire this way or that way, and they just kind of ignore it because they can't really put their finger on it. Um,
Maybe when we
you
have
know,
a fully working model one day, we can suggest a renaming of layers.
yeah.
Because I guess
I
a lot
was
of it's
struck.
just history. Like first they
I was
notice
always
these bigger layers, and then it's like, oh, maybe they're smaller layers.
right, right. I
I think
remember,
probably a lot of it does go back to histology. You look at mouse visual
right,
V1,
Right.
2
Yeah.
and
Or
3
like,
right,
look kind of,
and it's like once
right.
you want to add a layer, what do you do? Like one of my friends who lives in Germany, his property is called like L is 15B, and it's because like they already had a 15, 16, 17, and then someone built a new house in between these, and then it's like we
Right,
can't add a
right,
number, so it's gonna be
15.5.
15B,
right,
15.5.
right,
didn't we already
right.
invent a system for this?
Well,
It's called the
that's what
real
they did
numbers.
here. That's exactly what they did here, right? I mean, oh well, look, there's two different types of cells in layer five. Okay, we'll call them 5A and 5B, right? And what you're right, it goes back to histology. They took a quick look at it and said, well, somebody counted 6 layers, and they went with it.
Yeah, I guess it's also
So,
confused. Like this other paper about layer two and three, it says, as past studies have lumped together the non-directional cells in layer two with mixture of directional and non-directional cells in layer three, the true prevalence of direction selectivity in layer three has been underestimated. So basically, like
Interesting.
lumping two and three together made it less clear that layer three is actually quite direction selective. Um,
I see. And this one
layer
says that
two
layer
seems
two is
to
not
not.
directly sensitive. Is that
Yeah,
what it
they're
says
not.
here?
Yeah, it says
So,
layer two is not. Let me see
right,
if I can find the
which would be
statement.
good. What you would expect for a voting layer, right?
Yeah,
You don't
I'm not
really
sure.
want.
Just from a
Can you show
glance
us the
with
title
one.
of this
Uh,
at some point?
Physiological differences between neurons in layer two and layer three.
Okay, thank
So
you.
this is studying on physiological differences. The paper I was doing was mostly anatomical connection differences. Um, there was some place I read that was suggesting that, and I mentioned this to Vivian the other day, that layer two and layer two seems to be like it's almost like a voting layer that's going down the hierarchy, something like that. Information flows down from upper regions to lower regions. I don't know if that's true. I mean, people make this stuff up. Um, So, like, oh, it is one of those cases where you can read 100 papers and you walk away like, I don't really know what the hell's going on here. Everyone seems to be disagreeing about this, and there's no consensus on what this all means.
Yeah, this paper actually also suggests that in the end that uh, yeah, the lesser selectivity of layer two cells may participate in top-down influences from higher cortical areas as well as modulatory influences from subcortical brain regions. And also this
Um,
recent paper from the Allen Institute, they also talk about actually there I wasn't sure where they got this from. I didn't see in the text where it talked about it, but basically
but
that
but
layer two gets the top-down influence and layer three gets the
all right,
bottom-up
right,
input.
right. Well, but you read what you just read there is they said since we didn't see this selectivity that we expect to see in V1, for example, we're assuming this is coming from top down. It didn't mean that they saw those circuits projecting from top down. They're saying, well, if the cell doesn't seem to respond to like every other cell in this column, well, maybe maybe it's coming from top down as opposed to, oh, this is where the connections are.
Yeah, yeah, like
Yeah,
with layer three, they clearly said, okay, we saw input from LGN here, but layer two, I didn't see them look into where
I
they
mean,
actually.
our pooling mechanism, temporal pooler, would result in cells that don't show selectivity to the rest of the cells. They wouldn't show orientation selectivity or movement selectivity. And so, people might say, "Oh, those are top-down influences." No, no, it's just temporal pooling. It's so they reached the wrong conclusion.
Yeah, and I guess while we're going through papers, I was just having a quick look when you were talking earlier, Jeff, and just yeah, in terms of you were talking about L4 input to L23, in terms of the particular feature you're seeing, potentially predicting behavioral state. And I was just curious
Here
about
they're lumping
feedback.
2, 3 together.
Yeah, here they're lumping it together. So forget about distinction within L2, L3. But
Yeah.
but I guess the main point, so that this A subpanel is excitatory cells to excitatory cells. But the point is this 2.7 going back from L2, 3 to L4
So they're
suggests
starting
that
to go
this
to the
is
back,
actually
but
fairly recurrent. But that
yeah,
would be nice from the point of view of bringing in the behavioral state and having that kind of bilaterally coupled to
right, right,
specific
right,
representations in
right.
L4.
Yeah. But you have to do that for
But are
you have
these
to do that
driving?
uniquely for every.
Well, it's excitatory. It doesn't go into detail whether it's
I see, I
driving,
see.
but it's
I don't think
definitely, these aren't inhibitory. All of these other ones are different.
most of the cells we think about, aren't, at least as part of the time, they're not driving cells, right? They're predictive states. Um, the main thing that we actually know is driving this is you got some retinal input, say, coming into V1 or V2. But it's also, there's been, it's quite likely that sometimes, where you have an associative connection, just put cells into a predictive state, it's not driving, and other times it could drive them. So, like does, right, I know that it could easily be variable. Um, you
Like, do
want
you
to
want to go
summary?
through the rest of the questions, or should we
Oh
stop
yeah,
now?
no, I'd like to go through the rest of your slides. Can we do that?
Okay, yeah, I'll go quick and yeah. I guess the other one we also mentioned already is like Rami brought this up, like how do we apply behavior to morphology model to keep making correct prediction about morphology? And yeah, I guess the one proposal was the same mechanism as before, apply the inverse of the stored movements to the child's reference frame. The other one that Niels mentioned, yeah, basically the union of like keyframes or possible features at locations and that being tied to states in the morphology in the behavior model. I guess this one applying the behavior that requires kind of learning a backward mapping of these pooled changes and how that translates to movement in a reference frame. And yeah, it's not clear, at least to me, how it would work for movements that aren't translation or orientation of a child object. If it's more like expanding or wobbling movement or something like that.
Mm.
This one we also mentioned about the orientation. I don't think I need to go into that again. No. Oh, I guess just one example I had where it was I'm
Did you
sure
did you find that did you find that image, or did you have like
I
ChatGPT
made
make it for you?
ChatGPT generate it for me. I had a bit of trouble. First, I asked it, first image it put like the whole American light switch plate on it with it, not just the rocker. And I was like, no, just put the rocker on there. And then it was like this little white piece pointing out, but it was like clearly impossible to rock it. It was like grown into the shape. It's like, this looks impossible to rock. So, okay, here you
This is
go.
this is a pretty good one.
Yeah, yeah. But anyways, basically, if we only have one orientation, like one other question I had around that was like, how would we assign the same behavior on a parent object in different orientations and locations? Like, we have the rocking
Mm.
behavior on multiple locations and different orientations on this object. So how would that work if we can only have this morphology orientation to transform the input?
The way when I look at this image, I look at the top switch. In my mind, it's almost like I'm imagining there's a plate for that switch, and that whole plate is now horizontal. And
I thought we
um,
weren't allowed to do that. That's what we and I wanted to
I
do in
know,
Milan.
I know. I'm admitting it. I'm imagining that. It's almost. It feels like it. I don't actually see the plate, but that's how it feels to me. It feels like I don't see that switch in its native orientation. I see it as if it was moved and laid flat and rotated. Anyway, we've talked about this before, but we don't
Yeah, I
have
mean,
the
I'm
answer to
happy
that
with
yet.
going back to the imaginary switch plate or like
It's
parent
more like
object.
is there a reference frame that that doesn't actually represent a parent object but would,
Yeah,
and the switch is part of that reference frame and it moves relative to that reference frame. So the switch is not moving relative to the cylindrical object. The switch is actually moving relative to the imagined plane of the switch, um, which is not the same as the reference frame of the cylinder.
yeah, yeah, and that would
Yeah.
solve this
All right. So
issue.
maybe that's what it is, and it feels that way. Just looking at this picture again, I don't think we have to have a physical plate. It's just sort of like the switch is rocking relative to a reference frame that has no physical manifestation at this point. Well,
Yeah.
happens to be aligned as a child object. Okay, that's an interesting observation.
And then, yeah, I think we briefly touched on this last week as well. Which region would the behavior model be stored in? So would it be stored in the same column as the top of the stapler? So the child object that it's referring to, or would it be in the column of the whole object and basically saying, okay, this behavior is on these locations on the parent object. And so, yeah, if it's in the column together with the child object, that would mean that L3's receptive field is larger than L4's, which we said is a possibility. Um, it's unclear how it would work when the child behavior is defined relative to a parent, but as we just said, maybe there's imaginary reference frame, maybe there's kind of some top-down connectivity telling us the orientation of the parent object. So nothing we couldn't work around. If it's in the column of the parent object, uh, I'm not sure yet how it would work to associate the behavior model with specific locations on the morphology, although, yeah, like you said, Niels, we could use layer 3 to layer 4 connections since features in layer 4 will be kind of unique to locations as well. And then, yeah, applying the parent orientation to the behavior would be less general. That's kind of the issue with pointed out here that yeah, just one orientation for this many kind of local behaviors doesn't seem sufficient. So going through this right now, I would almost tend towards having it in region 1 with the child object, but earlier when I made the slide, I was tending towards region 2, and I think last week too, so I don't know.
All right. Well, maybe we don't have to decide right now.
Yeah, just an open question. And then, so lastly, I just went back to this list we made last year about all the requirements for behavior models. And with the previous solution with reference frames, we had pretty much all of them green. Some of them were kind of still a bit problematic, like recognizing behavior with a single column, for example. But just kind of going through this again, I thought would be useful. And again, most of them are green. Some of them I wasn't sure yet what our answer would be on. Some of them I marked as problematic, although now talking through them, maybe they're not. So yeah, learning a model of a behavior, we need to be able to store arbitrary changes in features and morphology over time. And so I think if we say that we can use a general spatial pooling for the most common changes, including features, then that could all be green.
Well, we didn't talk. Today we just talked about changes in morphology. We didn't talk about like lights turning red and green.
Yeah, well, yeah, that's what I meant with if we do a general spatial pooling of
Yeah,
changes, then that could be learned as one of those changes, commonly observed changes.
and maybe.
Um, but yeah, so I'll leave it orange for now. I guess something to figure out.
Yeah.
This one is actually easier with this new solution to be able to observe all the changes such that the model can be learned in a column while the object is going through the behavior. Then, yeah, recognizing object behaviors on the same object as learned on a different object in arbitrary locations, orientation, and scale. I think that also works because they're not tied together, even though they're in the same column. The orientation one and scale are still marked as kind of orange because I wasn't so clear yet on how the lack of orientation representation for the behavior model would affect this. Then where in the sequence we are and the speed, I think we would just use the existing mechanism with the global speed parameter and layer 1 input. So nothing that would change there. And then recognizing the behavior with a single and multiple columns. I think with a single column is now possible and much easier, but I wasn't quite clear on in what situation we would actually use multiple columns now and what the advantage there would be if a single
Right.
column already gets input about the entire object's behavior.
Well, maybe this will be relates to the attention ideas I was talking about.
Yeah.
You know, like something weird going on.
Yeah, and again, this wouldn't be an issue if we just say, well, we can just do it with one column now. We don't need multiple columns anymore. But it just left it as something to think through more.
Mhm.
And then learning associations between object and behavior. So seeing a static object and inferring the behavior, as well as seeing a behavior and biasing the object. I think there we kind of suggested maybe layer 3, layer 4 associations.
I think they do that, especially the first one. Yeah,
Yeah.
the layer 4 projecting the layer 3 is 3B, that does that.
Yeah, so yeah, I guess then we could mark that as green as well. And then one object can have multiple behaviors, which is still possible. Behaviors can be in arbitrary locations, orientations, and scale on an object. Yeah, again, I wasn't sure about the orientations and scale on an object. Those, I think, details aren't so clear for me yet. Like the light switch on the cylinder, the multiple light switches on the cylinder. But probably possible. And then making predictions about an object at an arbitrary point in the behavior sequence. So again, that was in the open questions. Do we use the kind of mechanism of applying stored movements? Does that work in all cases? And then, yeah, if part of the behavioral sequence is occluded, or we do a saccade from one point to another. Again, there was the idea we could simulate the sequence doing inference instead of doing smooth pursuit the whole way.
I don't know.
Yeah. That's the kind of high level view. I think, yeah, I didn't see any total red flags of this is impossible, just various open questions. And then, yeah, I don't know if we want to talk about movement outputs. It's been a long meeting, but basically what you wrote on Selective, that this seems like a nice mechanism to generate movements that we can basically replay a sequence until the goal state is achieved in layer 3, and that projects to layer 5, which then outputs a movement, which could be direction plus velocity. And then similarly, the morphology model could calculate displacement to a target pose, and that would then could also be a direction and velocity output from layer 5. And basically the difference being that behavior models would be about achieving goal states, and morphology models would be about achieving target poses because they have a reference frame and can do path integration. That's
Yeah, I
it.
like
I
that.
made it.
I thought that was I was happy with this unifying those two types of goal state and target pose with a single output.
Yeah.
Seemed nice. Seemed nice. Great.
Nice,
Now
thanks.
you can
That was really
summarize.
helpful.